Yes, you are welcome to this lesson today. We are going to be looking at the general equation of a straight line. Our learning objectives for today's lesson will be to understand the general form of the equation of a straight line. We are also going to see how we can determine the gradient, the y-intercept, the midpoint, and the length of a given line segment. And finally, we are going to see the relationship between the gradients of a parallel and perpendicular. Now, the general form of the equation of a straight line is y equal mx plus c. If we recall from our previous knowledge, we know that m in this case stands for the gradient, while our c is the y-intercept. The gradient is otherwise called the slope, while the y-intercept is the point where the line cuts the y-axis. Now, to calculate or determine the gradient and the y-intercept given the general formula y equal mx plus c, we have told to find the gradient and y-intercept of this line, y equal 3x minus 4. When we compare it to a general form, we will see that our m, which is the gradient, is 3, and our c, which is the y-intercept, is 4. So that gives us a gradient of 3 and a y-intercept of minus 4. Example 2. Find the gradient and y-intercept of the line 2x plus y equals 6. Same thing, we place it, we compare it to the general form. There we see that our m is minus 2 and our c is 6. It is worth note here that whenever you are given an equation, you have to make y the subject of the formula before you pick out your gradient and your y-intercept, as we can see in a second example. Therefore, our gradient will be minus 2 and our y-intercept will be 6. Y-intercept will be 6. Now, we can also be asked to find the gradient of a line when the coordinates of 2 points are given. In this case, we use the formula y2 minus y1 all over x2 minus x1, where x2 and x1 are the x coordinates of the 2 points, and y2 and y1 are the y coordinates of the 2 points. Let's take this example. Find the gradient of the line joining points 2, 1 and 8, 7. Now, our y2 in this case is 7 and our y1 is 1, while our x2 is 8 and our x1 is 1. If we substitute this into our formula, we have 7 minus 1 all over 8 minus 2. That gives us 6 over 6. 6 divided by 6 is 1. So the gradient of the line joining those 2 points is 1. Let's try another example. This time around, the points are minus 2, 1 and 4, 5. We apply the same formula, m equal y2 minus y1 over x2 minus x1. We have to identify our terms. x1 is minus 2, y1 1, x2 is 4, and y2 is 5. We substitute our formula, we now have 5 minus 1 all over 4 minus 2. 5 minus 1 gives us 4. 4 minus 2 gives us plus. When the signs are the same, we add up. So we have 4 over 6. To the lowest term, our gradient becomes 2 over 3. Let's take a third example. This time around, our points are minus 1, 3 and 2, minus 3. X1 is minus 1, y1 is 3, x2 is 2, and y2 2 is minus 3. So we substitute into the formula for the gradient of a line. That gives us minus 3 all over 2 minus 1. That gives us minus 6 over 3, which is minus 2. So this is a negative sloping graph. Now we are moving on to equation of a line. To find the equation of a line passing through 2 points, the first step is to determine our gradient. We can either determine our gradient either by using the diagram or by using the formula we already learned. If we use the formula, we will get half. If we use the gradient, which is rise over run, that also gives us 1 over 2. Then the next step is to find our y-intercept. The y-intercept is the point where x is equal to 0. From the first coordinate given, where x is 0, y is 3. That means our y-intercept is 3. Knowing our m and c, we substitute into the general equation of a straight line. Y equal m, in this case it is half, and c is 3. So we have y equal half x plus 3. Let's try our hands on the second example for the points passing through minus 1, 4 and 5, 2. We find the gradient. In this case, the gradient is minus 1 over 3, and we find our y-intercept. The y-intercept, when we substitute our values, our y-intercept will be 3 whole number 2 over 3. To find your y-intercept, you can use any of the two coordinates. You use any of the two coordinates with the general equation of a straight line. So we have our m and our c. We substitute into that general form. That gives us our equation. Now we are moving on to the midpoint of a line. The midpoint of a line, it can be found either using the rule or a diagram. Preferably we are using the rule in this case. The median, the mean of the two x coordinates and the mean of the two y coordinates. That means x1 plus x2 divided by 2, y2 plus y1 divided by 2. So we are asked to find the midpoint of 1, 6 and 9, 2. We add our x coordinates together. We have 1 plus 9 divided by 2. That gives us 5. Then 6 plus 2 divided by 2. That gives us 8. So the midpoint of those 2 points will be 5, 4. Similarly, we do the same thing with this. Let me give you some seconds to try it. You pause the video and try it. Good. You get the mean of the x coordinates, get the mean of the y coordinates. Okay, let's play on our video. So the mean of our x coordinates will be 2, while the mean of our y coordinates will be 3. So the midpoint will be 2, 3. We do the same for the third one. That gives us minus 6 over 2, which is minus 3, and then minus 12 over 2, which is minus 6. So the coordinates of our midpoint is minus 3, minus 6. Now the length of a line segment, how long the line segment is, or the distance between 2 points. This formula has been derived from Pythagoras theorem. We find the difference between our x-axis, we square it. The difference between our y-axis, we also square it. So for those 2 points, we have 9 minus 1. That's the difference between our x coordinate, we square. The difference between our y coordinates is 2 minus 6, we square. That gives us 8 squared plus minus 4 squared, which is 64 plus 16. That gives us root 80. We could either express our answer in short form or in decimal, so the length will be 8.9 units. 8.9. For a second example, we have to find the length of the line joining the 2 points. Yes, so that gives us that. 148. The square root of 148 is 2 root 37, or 12.2 units. Perpendicular lines and parallel lines. Perpendicular and parallel line. A line is parallel to y equals 3x minus 4 and passes through the point 5, minus 1. Find the equation of the line. We know that the equation of the line is y equal mx plus c. Our m is 3. Now, parallel lines have the same gradient. If two lines are parallel, their gradient would be the same. So in this case, the equation we are looking for, the gradient is 3. So the next thing is to find our y-intercept. We use the point 5 and 1, we substitute into the general form. So that gives us c is minus 14. Once we have our m and our c, we substitute it in the equation. So the equation becomes y equal 3x minus 14. We try the same thing, but this time around, the equation, the lines are parallel. So if our m is 4, to get a parallel line, our m for the line we are looking for will be minus 1 over 4. This has been based on the fact that for perpendicular lines, the product of their gradient is always equal to minus 1. The product of the gradient of perpendicular line is always equal to minus 1. So we find our c. We substitute 0 and 23 in our equation. So that gives us c will be 23. Once c is 23 and our m is minus 1 over 4, then the equation of the line becomes y equal minus 1 over 4x plus 23. Our classwork. Now let's lay our hands on this classwork. We pause the video and have a go at it. You have a go at it. You have 10 minutes to do this activity. If you are done before 10 minutes, you go to the extension activity. If you are done with your activity before the end of the 10 minutes, then you lay your hands, you try out the extension activity. Good. Having done the exercise for 10 minutes, you can now continue play the video. So when you continue, you realize that the gradient for the first one is 3 and the midpoint that. Now you check your answers to be sure you are right. Yes, you check. If your answer is your gradient is correct, you have a point. Your midpoint is correct, you have a second point. If your length is correct, you have a point, and the equation is correct, you have a second point. Good. This should be over 10. You can now mark your work over 10. Now, we summarize our work for today by looking at equation, general form of equation of a straight line, the gradient of a line, the midpoint, the length of a line, when we have parallel lines, the gradient, and perpendicular lines. Thank you for watching this video. You can practice more exercises to perfect your skills on equation of a straight line. Have a nice day.